we would like to write the first 5 terms of this sequence. Now, before we do that, you see this term here? This occurs a lot. This type of thing occurs a lot. Let's just take a look at that for a minute here. You have negative 1 to the n. Now, first of all, when n is equal to 1, right, we'll do a few of these. When n is equal to 1, what do you get? You get negative 1 to the 1, which is negative 1. When n is 2, you get negative 1 squared, so you get 1. When n is 3, you get negative 1 to the third, which is negative 1. And then we'll do another one. When n is 4, you get what? Negative 1 to the fourth, which is positive 1. All this thing does is alternate between signs. Negative, positive, negative, positive. So this is, I like to see it as what I call an alternator. It's just going to alternate between those numbers, 1 and negative 1. Now here's an idea with this. You know that when you do something like this, if you take negative 1 and raise it to an even power, you're going to get a positive 1. If you take negative 1 and raise it to an odd number, you're going to get negative 1. And that's all that's happening up here, right? What do you have? You have negative 1, and you're going to go through 1, 2, 3, 4, 5. So just look to see if this is odd or even. Now, what I'm going to do here is replace n with 1, 2, 3, 4, and 5. So first of all, at n equals 1, what are we going to get? We'll get a sub 1. Now what I'm doing is I'm replacing all the n's in my formula with a 1. So I have it here. A sub 1, the first term. And if I put a 1 here, now that's going to be, let's do the first one here. This is going to be 4 plus negative 1 to the 1, but I know that's an odd number, right? That exponent is odd, so this is just going to be negative. So what I'm going to get here is 4 minus 1, I get 3. Now when n is 2, we'll get a sub 2, right? Replacing that very first n here, up here on the left with a 2, all right? And that will give us 4 plus negative 1 squared. But now I've got an even power on that negative, so that makes it positive, right? So this is going to be 4 plus 1, so I get a 5. All right, so I know the pattern for these things now, right? Here's the pattern. Even exponent, right, in my formula up here, even exponent is positive, a positive 1. Odd exponent is a negative 1. So what are we going to get for n equals 3? So a sub 3 is equal to 4 plus, now negative 1 to an odd exponent. So that's going to be 4. Now negative 1 to an odd exponent is negative 1, so I get a 3. N equals 4. I'll get a sub 4. The fourth term is 4 plus negative 1 to the fourth. So this is an even exponent. That's going to make that positive 1. So I get 4 plus 1. So I get a 5 out of this. And let's do one more. N equals 5. I'll get a sub 5 is equal to 4 plus negative 1 to the fifth. And that exponent is odd, so I know I'm going to get a negative 1. So this becomes 4 minus 1, which is 3. So if I just write the first 5 terms here, here they are. I'll just put them vertically. So what am I going to get? I'm going to get 3, 5, 3, 5, 3. There's the first 5. You can imagine what the rest of them are going to be.